Okay, the next component in the air conditioning is the cooling tower. The cooling tower CT are heat removal devices used to transfer processed water heats to the atmosphere. So, cooling towers may either use to evaporations of water to remove processed heats and cool the working fluid to near the wet bulb air temperature, or relay solely in air to cool the working fluid to the near the dry bulb air temperature. So we have three types of cooling tower by airflow generation methods, which is the first one is natural draft, the second one is mechanical draft, and the third one is a fan assist natural draft. So we can see the performance of the cooling tower using the range plus approach time hundreds, or the cooling capacitance. So this is the same formula that we use when we see the COP in a chiller, which is 4.1x times Q times differential temperature. Okay, so 4.18 is a constant value, Q is a flow rate, T in is the temperature returned, and T out is the temperature supply. So again, I like to remind all of you, if you use this formula, make sure the temperature that you take to do the calculations is at the same place.
Adalah cooling tower lah. Kalau tengok ada dua unit.
Again,
Dia dua chiller jalan.
I need to explain to
Biasa
you
akan cover untuk dua unit lah. Dia satu-satu
process in the cooling tower. This is a cooling tower
Atas
that
chiller
location
plant
of
tadi.
this cooling tower is at the tertiary buildings in UTM.
So air sampai sini dia akan proses untuk jadikan dia punya condensed water yang hantar balik ke chiller plant lah. Proses. Itu nak balance balik. So apa yang ada kat sini, dia ada motor kat atas tu. Kat atas tu ada motor, dia ada belt, dia ada kipas lah, dia ada macam kipas. Dah nak turun. Tak panas.
Takut tak? Baik.
Tak lepas ni.
Tak ada function pun. No, tak ada function.
Turun lah belah sini. Ambil video yang belah dalam.
Back video. Saya nampak yang boleh air tu. Atlet dia tahu atlet. Atlet, ya?
Lupa.
Yang mana tu tahu? Yang mana tu masuk?
Okey, itu adalah fan lah yang ada. Air yang ini akan condense dalam. So kat situ ada air yang return. Ni air yang return balik lah daripada chiller. So sana ada macam lubang tu, dia supply balik.
Mana lubang? Oh yang tu?
Di sana masuk. Ni yang return, dia akan condensekan balik lah. Kalau tengok buih-buih ni yang tadi yang kata kita ada chemical. Dia untuk rawat lah. Untuk dalam ni tak nak dia berkulat, cepat berkulat dan sebagainya. Tu maintenance punya part.
Kalau tidak tak ada letak pun tak apa sebenarnya kan?
Kena letak.
Kena letak.
Kena letak.
Letak air pun dia pun kan? Dia nak letak air pun dia letak.
Dia ada level dia lah.
Oh mak kau level bubui.
Okay, the last components in the air conditioning is the air handling units, or AHU. AHU is a device used to condition and circulate air as a part of heating, ventilating, and air conditioning system. Okay, so sometimes AHUs discharge a supply and admin return air directly to and from the spacer without the ductwork. Okay, so from here, Okay, this is the AHU. Inside the AHU, so we have 1, 2, 3, 4, 5, 6 components in the AHU, which is the first one is the supply duct, second is the fan compartment, number 3 is the flexible connections, number 4 is the heating and cooling coil, number 5 is the filter compartment, and number 6 is the return and fresh air duct.
Kita tengok air sejuk kan dihantar.
This video shows the AHU inside the AHU. Okay, so we have all the components and
balik
assets.
ke chiller balik lah. Okay, daripada sini wap air dia trip wap air lah, macam wap air dia kita tukar ke dalam bentuk hantar dalam bentuk apa udara lah kan. Ni kalau nak tengok kat sini ni supply masuk sini untuk return balik air.
Dia return pergi mana?
Ha?
Dia naik atas.
Return dia pergi ke chiller balik.
Chiller balik.
So dia tak campur cooling tower dengan chiller. Another part, yang ni dia part untuk dia nak supply angin sejuk lah. Dalam ni ada motor.
Kalau kat FTK tu dia dua-dua kan? Dia ada chiller, dia ada cooling tower kan?
Kat sini pun ada.
Oh, okey. Tapi kami tak ada control room.
Kat sana tak ada control room lah. So suhu boleh tengok kat sini juga lah. Kalau kita nak tallykan kan, takut ada losses. So biasa kita check juga suhu yang dekat supply tadi sama tak suhu sini. Ada relatif banyak tak beza dia. Oh kita check lah.
Control room tu semua dah boleh nampak?
Boleh. Boleh tengok. Okay. So daripada sini kita hantar angin sejuk Melayu ni lah. Tu sana ada damper Damper tu untuk fresh air. Biasa kita akan buat room data survey. Bila room data survey, kita tengok CO2 dia banyak sangat, terlebih daripada 1000 ke atas 900 ppm. Biasa kita akan buka damper sikit supaya fresh air boleh masuk. So nak balancekan balik lah udara dalam tu.
Yang ini pergi ke office lah kan?
Pergi ke office.
Okay guys, actually we have a monitoring room, or we call it as BMS, Building Management Systems, to monitor all the operations in the chiller, cooling tower and the AHU, to monitor the switchable temperatures that's been operated in the air conditioning system. So we can see from here we have a CT1 and CT2 is for cooling tower 1 and cooling tower 2. We have a AHU and we have a chiller plant. As I said before, as Dr. Fani explained to all of you, we have 3 chiller in Chancellery buildings. So we have 3 chillers, but only 2 chiller is operated. Okay. And 1 chiller is for standby. So you can see chiller number 3, this chiller number 3, okay, you can see in the middle here. So chiller number 3, its supply to the AHU is around 7.9 watt, and return back to the chiller is 11.46 supply. So the differentiates here is 1146 minus 7.91 to say the COP of your chiller. Alright, so if you look at to the chiller number 1, the differential is 16.55 and 22.64. Okay, so since it's not using, we are not using this chiller number 1, so it's okay. Alright. Okay, beside then the temperature, we also can measure we can see the value of flow rate and the parameter of the chiller, and also during using this building management system BMS, you can see not only in the chiller plant, but we can see at the AHU and also in the cooling tower. Okay, now For auditing in the air conditioning systems, we have the desktop audit, which is in the desktop audit, we have a system design and equipment data. And for the system audit, we have overall efficiency and or the COP, which is for this time, for the system audit, you need to calculate, you need to do the measurement of the room temperature and humidity, and the equipment audit, which is the AHU audit. You need to set an actual parameters, air and water systems, the fan motor power input, and the control system, whether you use the BMS or the BAS. Okay. For the desktop audits, the system design air conditioning system equipment, we have a chiller, chill water pump, condenser water pump, cooling tower, and AHU. Okay, this is an example of the system design, which is we need to find the layout of the system. Okay, so from here, from this layout, you can see the cooling tower, the chiller number 1, chiller number 2. Okay, this is from the also from the system designs. We will find the status of the AHU. Okay, this is the AHU summary in AHU. So we can see the airflow, the cooling water supply, cooling water returned. Okay, so same like this is in AHU. Okay, you can see the cooling water return, cooling water supply, the set point, the status. Okay, so the second one is the equipment data. So the equipment data, you need to find all the data for your equipment. For example, chiller number 1, what's the manufacturer for this chiller, the model number, capacity, operation mode, operating systems, the ampere, power factor, and so on. Okay, so same like this, as I said before, in chiller we have a pump. So here we have a pump 1, pump 2, and pump 3. So you need to know the data for this pump. Okay, for the cooling tower and at the operations at sites. Okay, so the next one is the system energy audits, which is for the chiller plant or building. So the equipment to be audited is total power, chiller, chill water pump, condenser water pump, cooling tower, and also the Okay, here are the list of the building measuring equipments that we can use this equipment to measure in a chiller plant, which is the first one is the ultrasonic flow meter, the second one is temperature meters, then power meter to find the power, okay, to calculate the COP, and the last one is the temperature or humidity meter. Alright, so we can use this form to get the air conditioning system data, okay, the cooling tower data, chill water pump, and condenser water pump. Okay, this is the plan data of the system energy audit. Okay, so for AHU, we can use the air velocity meter, temperature meter, power meter, and also the temperature humidity meter to measure the suitable values in the AHU. Alright, so you can use this form, okay, equipment audit in AHU. Then we can observe AHU coil conditions to see that this AHU is okay or not. So you can see from here there were 6 nodes AHU with the supply air more than 100%. So there is a potential reduction of motor speeds that will create savings using frequency reduction methods, and 18 nodes AHU with loading drop by more than 30%. So this might be due to the AHU being oversized or exhaust air leakage into outdoor airstream. Okay, so you can see the observations of the comfort level. So you can see the room data survey, the temperature. You can calculate the you can measure the carbon dioxide and also on. Okay, so for energy audit recommendations in the aircon, we can do the chiller management, the chiller compressor optimizations, the condenser tubes cleanings, cooling tower cleanings, and reduction of outside air. And we have 10 tips. Actually, these tips is to improve the chiller efficiency, which is the first one. You need to keep a daily log, keep the tubes clean, treat the condenser water, reduce entering water temperature, control the water velocity, maintain refrigerant charge, analyze compressor coil, and checking wiring, and the last one is modulate speed. Okay, so from this BMS, we can see the operations or the performance of your chiller that you can see from here. on Saturday and Sunday, the chiller is not proper schedule or control. Okay. So that's all for today. Thank you guys. Bye. See you again.